Today we're going to talk about direct variation. And two variables, x and y, show direct variation provided that y equals a times x and a is not 0. And the non-zero number a is called the constant of variation, and y is said to vary directly with x. Okay, wah, 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 wah. I understand that's a lot of words. So let's go ahead and solve this first one for y. And then I'll explain in the example how you can tell whether it's direct variation. Okay, so if I want y on one side of the equal sign by itself, okay, I'm going to go ahead and I'm going to subtract 2x from both sides. Okay, so we're solving it for y. Negative 3y equals negative 2x, right? All I did was subtract 2x from here, and I subtracted it from 0. So now I'm going to divide both sides by negative 3. Negative 2 divided by negative 3 is 2 over 3. So for it to be direct variation, it has to be y equals some number. Oh, you can't even see that. It has to be y equals some number times x. So is this y equals some number times x? Yes. Okay, and then the constant of variation is the number that's x is being multiplied by. So in that case, it's 2 over 3. Okay, let's look at number 3. How do I get rid of this negative x? I'm going to add it to both sides. So when I solve this one for y, I end up with y equals x plus 1, right? It's 1 plus x. I'm putting it in with the x first. Okay, is this in y equals ax? No, it's ax plus something. Okay, we can't have anything added here, so this is no, right? You can only have y equals a times x. This is y equals a times x plus something, which we don't want. So there's no constant of variation because it's not a direct variation equation. So on this next one, how are we going to get rid of this 4x? We're going to subtract it. And then we're going to divide both sides by negative 5. Negative 4 divided by negative 5 is 4 over 5x. So yes, this models direct variation, and the constant of variation is 4 over 5. So why don't you guys try the last row? Okay, pause it and then come back, and we'll see if you get it. Okay, for this one, when you solved it, you should have got y equals x plus 4. Right? Because to undo this negative x over here on the left, I'm going to add positive x to both sides. So because I'm adding something, it's not direct variation, and therefore it doesn't have a constant of variation. On this one, we're going to go ahead and subtract 2x from both sides. So y equals negative 2x, right? I just subtracted 2 x's. So yes, it's direct variation, because it's y equals a times x. The constant of variation would be negative 2, because that's what x is being multiplied by. And on this last one, you should have added 3x. So you have 6y equals 3x plus 12. And then when you divide by 6, you get 1/2 x plus 2, because 3 divided by 6 is a half. 12 divided by 6 is 2. So yes, it's direct variation, and the constant, oh, no. Hello, Miss McNally. It is not direct variation. Why? Because of this plus 2. So that's a no. So it says, notice that a direct variation equation, y equals ax, is a linear equation in slope-intercept form, y equals mx plus b, where m is a and b is 0. The graph of a direct variation equation is a line with a slope of a and a y-intercept of 0. So the line is going to pass through the origin. Okay, so if it's y equals mx plus b is our slope-intercept form, all it's saying is that when you have the formula y equals ax, or the equation y equals ax, that's like saying this is your slope, and the y-intercept is always 0. So we're going to start here on 0. And then we're going to rise 2, run 3. Rise 2, run 3. So it's going to go like this. Or remember, I can go down 2 over negative 3. Down 2 over negative 3. So that's what my line will look like. Here we're starting at 0, down 3 over 1. down 3 over 1, or up 3 over negative 1. Okay, and then this last one, we're going to divide both sides by 6. So y equals negative 2x. The y-intercept is 0, down 2 over 1, down 2 over 1, down 2 over 1, or up 2 over, like this. Okay, so they're essentially, all it is a linear equation, like a y equals mx plus b, where b is always 0. You're always going to start at the origin. Okay, so let's look at this next one. It says the number of tablespoons of salt needed in a saltwater fish tank varies directly with the number W of gallons of water in the tank. A pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. Hold on, I dropped my pen. Okay, so it says, whoops, write a direct variation equation that relates W and x. Okay, so the first thing that we're going to do is write that equation. So what do y'all think? Okay, so we know that what he's saying is that it's 100 tablespoons, okay, correct, for 20 times A, correct? There are 100 tablespoons for a 20-gallon tank. Okay, can we agree with that? Okay, we could also, if we're gonna, we could say that it's like saying the S equals A times W. So the amount of salt equals some constant of variation times the amount of water. Okay, so if I know that it's 100 tablespoons of salt for 20 gallons of water, then if I divide both sides by 20, I'm going to figure out that it's 5 equals A. So the salt is equal to 5 times however much water, right? So when it was 20 gallons of water, 100 tablespoons, 5 times 20 is 100. So then it says how many tablespoons of salt should be added to a 30-gallon saltwater tank. So the salt is what's missing, right? And it's going to be equal to 5 times the amount of water. So that's 150 tablespoons. Okay, what if it was 25 gallons? The amount of salt is equal to 5 times 25. So that would be 125 tablespoons. Okay? So on this next part, it says the graph of the direct variation equation is shown. Write the direct variation equation, then find the value of y when x is 5. Okay, so we know that it's going to go through the origin, right? So now we just have to find the slope. So going from left to right, think about slope, dude. He went down 1, 2, 3 over 1, 2. So y equals negative 3 over 2x, right? Think about it, it's just a linear equation that's going through the point 0. So it says find the value of y when x is 5. So if I put a 5 in here, negative 3 over 2 times 5 over 1, I get negative 15 over 2, which would be negative 7.5. Okay, if you left it as negative 15 over 2, that would be fine. And it makes sense because if I went all the way over here, 1, 2, 3, 4, 5, and went all the way down, that would be negative 7.5. Okay, so y equals, I'm going left to right. Slope dude's going up, 1, 2, 3, 4, 5 over 1, 2, 3, 4. Is that right? 1, 2, 3, 4. So 5 over 4x, because that's the slope. The y-intercept is 0. Find y when x is 5. Well, what if I put a 5 in here? 5 over 4 times 5 over 1 equals 25 over 4. How many times can 4 go into 25? 6 times, with 1/4 left over. So 6 1/4, or 6.25. So let's look. When x is 1, 2, 3, 4, 5, Okay, mine's a little bit off, but it would be 6.25. Okay, it says tell whether the table represents direct variation. If so, write the direct variation equation. Okay, so what we need to do is we need to figure out, first of all, we need to know what y is when x is 0, right? The first thing is we know that when x is 0, y has to be 0 because it has to have the point 0, 0. So 6, 5, 4, 3, 2, 1, 0, right? If I backed that all the way up, okay, let's see what this is going to be. 12, 10, 8, 6, 4. See how we're going down by 2? 2, 0. So when x was 0, was y 0? Yes. So now we just have to find the slope, right? And it's the change in y. So how much is my y changing every time? It's going up 2. And how much is my x changing every time? It's going up 1. Because remember, slope is change in y over change in x. Okay, let's look at this next one. If I backed this up when x was 0, 5, 4, 3, 2, 1, 0. 7, 6, 5, 4, 3, 2. When x was 0, what was y? 2, right? So if I were to put this on a graph, when x is 0, y was 2. So did this one cross at the origin? No. So it's not direct variation. Okay, one more kind of problem. It says, given that y varies directly with x, use the specified values to write a direct variation equation. Okay, so we know that y equals ax, right? I'm telling you that it's direct variation. So now we're just going to fill these in. 15 equals a is what we're solving for, okay, times x, which is -6. So if I'm trying to look for a, what do I need to divide both sides by? -6. So 15 and -6 are both divisible by 3. So I get -5 over 2 equals a. Can we agree with that? 3 goes into 15 5 times. 3 goes into 6 2 times, and it's negative. So if I'm trying to write the overall equation, y would equal -5 over 2x. So I used the y and x that I was given in this equation, okay, to figure out what a would be. Once I had what a is, I put it in here. Okay, look at this next one. Y equals a times x. So if a is being multiplied by 3, we're going to divide by 3. So I get 4 equals a. So now that I know what a is, I can write y equals 4x. And look at it. Does y equal 4 times x? Yes. Okay, let's look at this last one. So y equals a times x. So if a is being multiplied by 1/2, the way we do that is we're going to multiply both sides by the reciprocal. So also, you can use some logic here, right? If a times 1/2 is 2, then all of a has to be 4. So our equation would be y equals 4x. And 2 is 4 times 1/2, so that makes sense.